Example 3, express the ratios sin A, tan A and cosecant A in terms of cos A. Solution: to solve the given problem, consider the trigonometric identity. That is, cos square A plus sin square A equals 1. To get sin A in terms of cos A, let us simplify the above identity, that is, cos square A plus sin square A equals 1. Sin square A equals 1 minus cos square A. Applying square roots on both sides, we get square root sin square A equals square root of 1 minus cos square A. On simplification, we get sin A equals square root of 1 minus cos square A. As we know that tan A equals sin A by cos A. Substituting sin A in tan A, we get tan A equals square root of 1 minus cos square A by cos A, since sin A equals square root 1 minus cos square A. Therefore tan A equals square root of 1 minus cos square A by cos A. Let's now find the value of cosecant A. As we know that cosecant A equals 1 by sin A, we get cosecant A equals 1 by square root of 1 minus cos square A. Therefore the ratios of sin A, tan A and cosecant A in terms of cos A are sin A equals square root of 1 minus cos square A. Tan A equals square root of 1 minus cos square A by cos A. Cosecant A equals 1 by square root of 1 minus cos square A. Example 4. Prove that cosecant A into 1 minus cos A into cosecant A plus cot A equals 1. Solution: we need to prove that cosecant A into 1 minus cos A into cosecant A plus cot A equals 1. Let us solve from left hand side to make it equal to the right hand side. Therefore, considering the LHS, we have cosecant A 1 minus cos A into cosecant A plus cot A. This is equal to 1 by sin A into 1 minus cos A into 1 by sin A plus cos A by sin A, since cosecant A equals 1 by sin A and cot A equals cos A by sin A. Taking sin A as LCM, we get 1 by sin A into 1 minus cos A into 1 plus cos A by sin A. This implies that 1 minus cos A by sin A into 1 plus cos A by sin A. By multiplying, we get 1 plus cos A minus cos square A by sin square A. Cancelling cos A terms, we get 1 minus cos square A by sin square A. This implies that sin square A by sin square A, since 1 minus cos square A equals sin square A. This is equal to 1 equals RHS. That is, cosecant A into 1 minus cos A into cosecant A plus cot A equals 1. Hence proved. Example 1. Express the trigonometric ratios sin A, secant A and tan A in terms of cot A. Solution: in order to express sin A, secant A and tan A in terms of cot A, let us consider the identity, that is, cot square A plus 1 equals cosecant square A. This implies that cosecant A equals square root of 1 plus cot square A. Now let us find the value of sin A in terms of cot A. As we know that sin A equals 1 by cosecant A, we get sin A equals 1 by square root of 1 plus cot square A. To find secant A, we consider the identity, that is, 1 plus tan square A equals secant square A. We get secant square A equals 1 plus tan square A. Applying square roots on both sides, we get secant A equals square root of 1 plus tan square A. This implies that secant A equals square root of 1 plus 1 by cot A whole square, since tan A equals 1 by cot A. On simplification, we get secant A equals square root of cot square A plus 1 by cot square A. Therefore secant A equals square root of cot square A plus 1 by cot A. Therefore tan A equals 1 by cot A. Therefore the trigonometric ratios of sin A, secant A and tan A in terms of cot A has been expressed. Example 2. Write all the other trigonometric ratios of angle A in terms of secant A. Solution: By using the identity that is, cos square A plus sin square A equals 1, we get sin square A equals 1 minus cos square A. Applying square roots on both sides we get sin A equals square root of 1 minus cos square A. As we know that cos A equals 1 by secant A, we get sin A equals square root of 1 minus 1 by secant A whole square. On taking secant square as LCM, we get sin A equals square root of secant square A minus 1 by secant square A. This implies that sin A equals square root of secant square A minus 1 by secant A. Therefore sin A equals square root of secant square A minus 1 by secant A. To find tan A we use the following identity that is, 1 plus tan square A equals secant square A. This implies that tan square A equals secant square A minus 1. Applying square roots on both sides we get square root of tan square A equals square root of secant square A minus 1. By simplification we get tan A equals square root of secant square A minus 1. Therefore tan A is tan A equals square root of secant square A minus 1. As we know that cot A equals 1 by tan A. Therefore cot A equals 1 by square root of secant square A minus 1. As we know that cosecant A equals 1 by sin A. This implies that cosecant A equals 1 by square root of secant square A minus 1 by secant A, since sin A equals square root of secant square A minus 1 by secant A. Therefore, cosecant A equals secant A by square root of secant square A minus 1. Also we know that cos A equals 1 by secant A. Therefore all other trigonometric ratios of angle in terms of secant A has been solved. Example 3. Evaluate sin 25 degrees into cos 65 degree plus cos 25 degrees into sin 65 degrees. Hint: evaluate this problem until it get in the form of cos square A plus sin square A equals 1. Solution: given expression is sin 25 degrees into cos 65 degree plus cos 25 degrees into sin 65 degrees. To get in the form of cos square A plus sin square A equals 1. Convert all cosine to sine before plus symbol, and convert all sine to cosine after plus symbol. Therefore cos 65 degrees can be written in terms of sine, using the complementary angles. That is, cos 65 degree equals cos 90 degrees minus 25 degrees equals sin 25 degrees, since cos 90 degrees minus A equals sin A. And similarly, sin 65 degrees can be written in terms of cosine as sin 65 degree equals sin 90 degrees minus 25 degrees equals cos 25 degrees, since sin 90 degrees minus A equals cos A. Therefore, given expression, that is, sin 25 degrees into cos 65 degree plus cos 25 degrees into sin 65 degree equals sin 25 degrees into sin 25 degree plus cos 25 degrees into cos 25 degrees. This is equal to sin square 25 degree plus cos square 25 degrees. This is equal to 1, since cos square A plus sin square A equals 1. Therefore, sin 25 degrees into cos 65 degree plus cos 25 degrees into sin 65 degree equals 1.